Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss application of derivatives. Application of derivatives. Exercise 6.1. Before starting the sums in exercise 6.1, we have to learn these notations. Throughout this exercise, we solve the problems based on the concept of rate of change of quantities. Rate of change of quantities. Okay, my children, how do you denote the rate of change in one variable? Let us see these sentences. Rate of change in x, generally we denote it by dx by dt. Here rate of change of a quantity means at an instantaneous time. Okay, my children, you have to understand like this only. You have to take that meaning. Rate of change in x means at a instantaneous time t, at t seconds. Throughout this exercise we have to differentiate the given function with respect to t only. Remember this point, my dear children. Rate of change, if you get anywhere this word rate of change, then we have to differentiate that given function with respect to t only, not with any other variable. Remember this point, my dear children. Okay, my dear children, right. See, first notation, rate of change in the variable x, it is denoted by dx by dt. Understood this point, my dear children? Right. Now come to the second point, rate of change in y. Just I changed the letter y. Here x I wrote, here I am writing here y. So how do you denote it? Dy by dt. Understood this second point, my dear children? Right. See the third point, rate of change in area. The sums will be given related to area of a circle, related to area of a square, area of a rectangle, like this. In that case, we have to find the rate of change, in area. How do you denote it? dA by dt. If they are asking find the rate of change in area, then it means we have to find dA by dt. Understood, my dear children, this point? Right. Now come to the next point, rate of change in volume. We have to find the volume, rate of change in the volume of a cube, in the volume of a cuboid, like this. We have to find rate of change in the volume of some solids. In that case, it means we have to find dV by dt. Understood this point, my dear children? Right. Similarly, rate of change in perimeter of a circle, perimeter of a rectangle, perimeter of a triangle, perimeter of a square, like this they will ask. It means we have to find dp by dt. Understood this point, my dear children? Etc. and so on. Understood all these 6 points, 5 points, my dear children? We extend the same concept to other variables also. Okay, my dear children, here variable is x, here variable is y, here variable is a, area, here variable is v, here variable is p. Understood these points, my dear children? We are differentiating these variables with respect to t. Means here what is the differential operator? D by dt. Remember this point, my dear children. Rate of change means the differential operator is d by dt, not d by dy. Okay, my dear children? Right. Now observe these last two points. Dy by dt is positive if the rate of change in the variable y is given as positive. It means y is increasing at a instantaneous time t. Vice versa, if y is increasing at a instantaneous time t seconds or time t minutes, it means dy by dt is taken as positive number. Understood this point, my children? Similarly, if dy by dt is negative, it means y is decreasing. In the reverse order, if they give when the y is decreasing, it means dy by dt should be taken as negative. Understood this point, my dear children? Right. Now come to the first question, question number 1. Find the rate of change of the area of a circle with respect to its radius or. Read this question carefully, my dear children. They are asking the rate of change of the area of a circle with respect to its radius. Understood this point, my dear children? When r is equal to 3 centimeters and r is equal to 4 centimeters. Into different situations, when r is equal to 3 centimeter is the first situation, and if when r is equal to 4 centimeters, that is the second situation. In these two situations, we have to find the rate of change of the area of a circle with respect to its radius. It is given clearly with respect to its radius. So what should we find? dA by dr only. If it is not given, then we have to find dA by dt. Remember this point, my dear children. If they ask only find the rate of change, then we have to find only dA by dt. But it is given clearly with respect to its radius. It means we have to find dA by dr, where A denotes the area of a circle. Okay, my dear children. Just observe the difference. Okay, my dear children. Right. Now come to the solution part. Let A is equal to pi r square. Do you know this formula, my dear children? Area of a circle formula, pi r square, where A denotes the area of a circle when its radius is r units. Do you remember this formula, my dear children? Right. What is given here? R is equal to 3 centimeters. First condition, R is equal to 3 centimeters. So we take this area, A is equal to pi r square. Now we have to differentiate this variable A with respect to R. Remember this point, my dear children. It is very important. Whether we have to differentiate with respect to t, or we have to differentiate with respect to some other variable. If it is not given like this, then we have to find dA by dt only. Remember this difference. Okay, my dear children. So what is the differential operator? dA by dr. d by dr of A is equal to d by dr of pi r square. I wrote here differential operator d by dr on both sides. Understood this point, my dear children? Understood this step? Right. This implies, what do you get here in LHS? dA by dr. d by dr of A means dA by dr. This is a notation. Okay, my dear children, is equal to, if you observe RHS, pi is a numerical coefficient. We are writing this numerical coefficient before the differential operator. So we wrote pi before the differential operator d by dr. Understood this part, my dear children? Of d by dr of, what is left here? R square. We wrote R square. Understood this step, my dear children? Right. This implies in LHS we write dA by dr is equal to pi into here d by dr of r square. d by dr of r square. It is in the form of d by dx of x power n. d by dx of x power n is equal to, what is the formula? N into x power n minus 1. By using this formula, we get this part 2r. Understood this RHS part, my dear children? Right. This implies we are writing LHS part as it is, that is dA by dr is equal to, by simplifying this expression, what will you get here? Finally 2 pi r. Understood this step, my dear children? Right. We have found dA by dr, that is equal to 2 pi r. Then the first part, what is the first part? R is equal to 3 centimeters. When r is equal to 3 centimeters, we have to find rate of change in the area of a circle with respect to r. So it is denoted by, this is a notation, dA by dr at r is equal to 3. It is read as dA by dr at r is equal to 3 centimeters is equal to 2 pi into, in this equation we substitute r is equal to 3. In RHS we substitute r is equal to 3. Understood this step, my dear children? Right. This implies that is equal to, by simplifying this term, what will you get? 6 pi. We got 6 pi. After that we have to write here units. What are the units to denote area of a space? Is centimeter square. Centimeter square. Square units. We use square units to denote area of a space. By area, what are the units to denote radius? What are the units here? We are denoting centimeter. So centimeter square per centimeter, not by, just we read as centimeter square per centimeter. Understood this part, my children? We have to write units also. After finding the value, we have to write units also in the final. Okay, my children? Understood? Therefore, dA by dr is at r is equal to 3 is equal to 6 pi centimeter square per centimeter. Understood, my children? Right. Now come to the second part. When r is equal to 4 centimeters, we have already found dA by dr. In this value we substitute r is equal to 4. In this result we substitute r is equal to 4. Then dA by dr at r is equal to 4 centimeters. dA by dr at r is equal to 4 centimeters is equal to 2 pi into, what is r value here? 4. 2 pi into 4. Understood this step, my children? Right. Is equal to, by simplifying this term, what will you get? 8 pi. And finally, what I said, we have to write units also. In the numerator, what is there? A. What are the units to denote area? Centimeter square. Here centimeters. So centimeter square per radius is given in the centimeters. So centimeter square per centimeter. Remember this part also, my children. Understood? Right. Now come to the question number 2, my children. See the question number 2. The volume of a cube is increasing at the rate of 8 centimeter cube per seconds. The volume of a cube is increasing at the rate of 8 centimeter cube per seconds. How fast is the surface area increasing when the length of an edge is 12 centimeters? Okay, my children, understood? This question is related to a cube. Okay, so let us assume that at any instant of time t, the edge of the cube is x units, surface area is s, and volume is v. We are assuming these variables at an instant of time t. Then v is equal to x cube. What is the formula? Volume of a cube. If x denotes length of a side, and of cube, x cube. And surface area, what is the formula for finding the surface area of a cube? 6x square. Do you remember these two formulas, my children? Right. And what is given here? dV by dt. The volume of a cube is increasing. The rate of change is given. The rate of change in the volume of a cube with respect to t, because here units, see, observe here, seconds means with respect to t only. So dV by dt is equal to 8 centimeter cube per seconds. This is given. Okay, my children? Right. Now let us take this equation. V is equal to x cube. From this equation we find dV by dt. From this equation what should we find? dV by dt. So we have to differentiate with respect to t. Okay, my children, we are differentiating this equation with respect to t. Right. This implies d by dt of v is equal to d by dt of x cube. Okay, my children, on both sides I wrote the differential operator. Understood this step, my children? Right. This implies in LHS d by dt of v is there. What is the value of d by dt of v? dv by dt. Understood this LHS part, my children? Right. Is equal to, come to the RHS part, d by dt of x cube. Here we have to use the chain rule because the variable is x, here variable is t. So we have to use chain rule. So it is in the form of d by dx of x power n. So I am using that formula. What is the formula? N into x power n minus 1. So I wrote direct here 3x square into, we assumed here x is taken as t in our mind. So we have to differentiate with respect to t. So dx by dt. Understood this part, my children, in RHS? Right. So we got here dy by dt is equal to 3x square into dx by dt. And What is given? X is equal to 12 centimeters. So in this result we have find dv by dt at x is equal to 12 centimeters. dv by dt is equal to 8 centimeters already given. So we use that result here. So dv by dt at x is equal to 12 centimeters is equal to, in RHS, 3 into what is x? 12. So 12 square into, we don't know the value of dx by dt. We wrote that as it is. Understood this step, my children? Right. This implies it is already given dv by dt at x is equal to 12 centimeters. That is 8 centimeter cube per seconds. It is already given. So we write that value here in LHS. Understood this LHS, my children? Right. Is equal to, by simplifying this part, what will you get? 432 into dx by dt. Understood this step, my children? Right. This implies from this equation we are finding dx by dt. So dx by dt is equal to 8 by 432. Understood this step, my children? Centimeters per seconds, because x denotes length of an edge. So its units is centimeters by dt with respect to t, means time is seconds. So centimeters per seconds. Understood this part, my children? Right. This implies dx by dt is equal to, by simplifying these two numbers, what will you get? 1 by 54 centimeters per second. So we have found here the value of dx by dt. But RHS. Understood this step, my children? Right. This implies ds by dt at x is equal to 12 is equal to, by simplifying these numbers, we get 8 by 3. We got numerically 8 by 3. After that, we had to write units. What are the units to denote surface area? Centimeter square. Units. So centimeter square per. Here, what are the units to denote time? seconds. So centimeter square per seconds. Understood this statement, children? Right.